All right, so hopefully yesterday wasn't too bad for you. Today we're going to do graphing, and much of it's going to be the same, ax squared plus c. So we did ax squared yesterday, and we're just going to add this plus c part in the problem. And it really doesn't change a ton, okay? But we'll go through and show you how it changes. Okay, so let's start off with just a pretty straightforward one. So yesterday, I'm going to way over here on the right, we talked about y equals x squared, and we said over 1, up 1, over 2, up 4. And then we flipped it over to the other side to get the 5 points, and that was the graph. Okay, so that's just there for a reference. All right, so I'm going to graph this one. Step 1 was to find the axis of symmetry. And we used that formula x equals negative b over 2a. And again, there's no b. The b is like 2x, 5x, negative 10x. There's none of that. Okay, if you look at the part way up here at the top, there's only a and c. So when there's no b, it's always x equals 0 for the axis of symmetry. Okay? 100% of the time. All right. This one will be slightly different. So step 2 was to plug in axis to find the vertex. So 0 squared plus 1, 0 plus 1 is 1. So the vertex is 0, comma 1. Remember, we take this point, or this part and this part, and combine them. Okay, so just remember, sorry, I did pause if that came back weird, but we're taking the axis of symmetry, and when we plug it in to create a vertex. Okay? So the vertex is 0, 1. Okay, and then, we'll pick our points, or pick our numbers to plug in. I'll plug in 1. 1 squared is 1, plus 1 is 2. So I plugged in 1, I got 2. 1, 2. And then I'll plug in 2. 2 times 2 is 4, 2 squared, plus 1 is 5. So I plugged in 2, I got 5. 3, 4, 5. And then, again, like I should have put it in there, I forgot to. The axis of symmetry was like 0. And it'll be 0 on all the ones today too. And so 1 to the right flips over, 2 to the right flips over. Okay. And if you notice a couple things, if you compare these two graphs, they look very, very similar. Just this one's up 1 compared to the top one. Okay. And so where does that up 1 come from? It comes from that plus 1 at the end. Okay. Also, if you notice, remember what was our pattern yesterday? Over 1, up 1, over 2, up 4. Oops. Why won't Jeez. It's weird. So like on this first one up here, over 1, up 1, over 2, up 4, what happened on this one? From the vertex, over 1, up 1, and over 2, up 4. Remember, it's the same pattern because this one up here is y equals x squared, and it's the same as what I have, it's just plus 1. So x squared is always going to be over 1, up 1, over 2, up 4. If I put a 2 in front of it, it's going to multiply the up part times 2. If I put a 3 in front of it, it's going to multiply the up part times 3. If I put, a 1/3, it's going to be divide by 3. If I put 1/2, it's going to be divide by 2. Okay? So, you're going to, same as yesterday, we're just going to have these pluses and minuses at the end. So when I don't have room on this screen. Like on this one, it was up 1, and that came from that 1 at the end. The plus 1 at the end meant the graph went up 1, and it went up 1. It's like the plus 1 that's on the outside. This one doesn't have one, okay, but it would be like the one in the front. Oops. When we, so we had this graph, and again, it's going to say compare to y equal x squared. So what's different is that one at the end, and all it did was move the graph up. So this is what's called a translation, and we're just going to say it's a translation up 1. Okay, so we're kind of adding these, what's called transformations that we talked about in chapter 4 and in chapter 6. So chapter 4, chapter 6, now we're in chapter 8. So hopefully some of these words are familiar to you. So if, let's see, so if I had negative 2x squared plus 3. So again, the axis of symmetry, because there is no b part, is 0. Okay. Vertex. When you plug in, you're supposed to plug it in. 0 squared is 0. 0 times negative 2 is 0. That's always going to be 0. We talked about it yesterday. When you plug in 0 to the x squared part, you're always going to be multiplying by 0. It's always going to be 0. I'm just left with plus 3. Okay, so for when there's no b part, there's some huge advantages to the graphing, because the axis is always 0, and the vertex is always 0, comma, whatever's at the end. That was minus 4, I'd put negative 4. Okay, if that was plus 8, I'd put 0, 8. 100% of the time, oh, I keep hitting that button. 100% of the time, that happens. There's never a time where that won't be the case. Okay, so when there's no b part, x equals 0, and then you're going to have the vertex 0, whatever's at the end. If there's nothing at the end, then it's 0, 0. That's why we had zeros yesterday. Okay, so when we go to graph this, the vertex is 0, 3, and the axis of symmetry, again, is right down the middle. It'll be like that on all the problems today. Okay, All right, now I need to pick my two numbers, and then I'll get to flip them over. So again, I'm picking 1 and 2. It's easy enough. So y equals -2, 1 squared plus 3. So with these, when there's more stuff, this part does take a little bit longer. -2 times 1 is -2, plus 3 is +1. So I plugged in 1 and got +1. Now I'm going to plug in 2. -2 to the second power is 4. -8 plus 3. And y equals -5. So over 1, up 1 from the vertex, 1, 1, and then 2, -5. And then I get to flip them over, the axis of symmetry. So 1 to the right, 1 to the left, 2 to the right, 2 to the left. So here we have, again, our upside down graph, which is caused by that negative sign in the front. Okay, so notice the vertex, instead of being at the very middle, it's up 3. This one, it's up 3, and that comes from the 3 at the end. So we'll have a translation up 3. And then the other when it says compare, this is what we need to list. Okay, so then we'll have a reflection over the x-axis because of that negative sign in the front. And then we'll have a vertical stretch by 2 because of the 2 that's next to the x squared. So you might, when you looked at it, let me copy it over because I wrote all that stuff. When you look at that, you see -2. I see -2. But when we talk about these transformations, I treat the negative sign by itself and the 2 by itself, and then the 3 at the end by itself. This will be the maximum amount that you have, 3 of them. Okay? In fact, actually there's, I guess there's 1 or 2that are like that. Okay? Just remember when you're doing these, if you get here, this green 3 meant the graph's going to go up 3, and the vertex went up 3. It's like this +3 that was on the out. It's just like the -2 in this problem. So it's like the 1/3 or the 2 fraction. So let's do one with a fraction. I'm going to change the -4. I'm just going to do -1. Okay, so right now you could tell like what the compare part is. Other than the x squared, what numbers do I have in there? Well, the -1 at the end means the graph's going to go down 1. So, just like over. So this -1 should mean that the graph's going to go down 1. So remember, axis of symmetry comes first. There's no b, so it's x equals 0. Vertex, when you plug in 0, all that's 0, so you're left with the number at the end. Zero, -1. And again, the axis is going to go down through the center like that. Okay, so when we pick our numbers and we have a fraction, if you don't mind working with fractions, pick 1 and 2, but you're going to get fractions and it's going to be weird. So I'm always an advocate of pick the denominator. So y equals 1/3, 3 to the second power is 9. 1/3 means divide by 3. 9 divided by 3 is 3. Minus 1 is 2. So I plugged in 3 and I got 2. Okay. Then what's the next bigger number that you can divide with 3? 6. 6 to the second power is 36. Yikes. And 36 divided by 3 is 12. Minus 1 is 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But it's 4, 5, 6. So it's way over there. So when we do fractions, we do get some kind of larger graphs, but 3 to the right, so 3 to the left, 2, 3, 6, 6 to the right, 6 to the left. And sometimes when they're kind of spread out like that, I just draw like each half of the graph kind of by itself. Okay. So there's our graph. Compare. Well, it went down 1. So we're going to have a translation down 1. Okay, and when we have a fraction in the front, that's going to be a vertical shrink by 1/3. It just means it doesn't go up as fast. And you might think, well, good night, it went all the way up to like 11. Well, that's when I went over 6. 6 squared is 36. If I didn't have that 1/3 in the front, I'd go up 36. So it's shrinking by how much? Divide it by 3. That's why we did the divide by 3 in the solving part. Okay, so here's one that only has 2. So if you have fractions, I pick the denominator and the next number bigger that works with the denominator. The only exception to that is if you have 4 as the denominator, you can plug in 2. 2 squared is 4, and 4 divides with 4. If it's anything other than 4, you pick the denominator and the next number bigger than the denominator. Like we did 3 and we did 6. Should have written it right here. This bottom part, we plugged in 6 and got 11 for our 2 points. Okay, so the transformations are really like what's different. Okay, so there's another notation involved with these transformations. It's like this -1 that was on the outside. It's just like the 1/3 in this problem. And let me show you that. So you're going to have some problems that it's going to, x squared plus 5. And then it's going to have g of x equals f of x plus 4. And it's going to say, what's the transformation? Describe the transformation from the graph of f to the graph of g. So this plus 4 on the outside means the same thing. So just like all those other ones, this number right here means translation. It's at the end, it's adding or it's subtracting. So this one would be a translation up 4. If it was -2, it would be down 2. Translation down 2. Okay, it means the same thing, just written in a different format. Okay, so if you had, and really this x squared part up on the top, it doesn't mean anything to the transformation. Okay, so if I put a 2 in the front of the f of x, those problems that I did, and that means it's a vertical stretch or shrink. If it's bigger than 1, it's a vertical stretch because I'm multiplying by 2 or 3 or 4 or whatever. Vertical stretch by 2. If it was a fraction, like we did our problem with 1/3, so let's say I'll use 1/4 this time just to be a little different. Okay, so like this one right here would be a vertical stretch, or excuse me, shrink by 1/4. The fractions mean divide. Okay, divide by 4. So multiply means like gets bigger, stretch. Divide means smaller, shrink. Okay, that's a way that you can remember those. Okay, and then if you had, again, this f of x part, doesn't mean anything. Completely ignore it. Okay, so I can put two things in this one. This negative in the front, remember that means reflection. And this positive one at the end, that's the translation. Up 1. So you could have more than one, but it's the same information, the same location. If it's plus or minus after it, it's a translation. If it's negative before the f of x, it's a reflection. If there's a number in front of it, it's a stretch or a shrink. Bigger than 1 is stretch, smaller than 1 is a shrink. Okay? All right. So you're going to have some that say, graph and compare, graph and compare. And then you'll have some that are going to say describe the transformation like we just did. It's going to say then graph both of them. You don't have to graph both of them. Okay? Just list the transformation. On number 13 and number 15, you're doing odd. So 13 and 15, just do what I just did. You don't have to graph. Okay? All right, then the last 4 problems, the directions are going to say find the zeros. The zeros of a graph so if I had, some graph like this, the zeros of the graph are where the graph crosses the x-axis. So the zeros of this graph would be 2 and -2. Write that a little different because that looks like a coordinate. Okay, the zeros are 2 and -2. Why do they call it that? Well, the coordinate of that point is 2, 0. And the coordinate of that point is -2, 0. So it's really asking, like, when is y equal 0? It's another way to think of it. Okay, so you're going to graph them, and then the answer is just where does it cross the x-axis? Okay, it doesn't matter. Let's kind of like, I don't know if weird is the right word or not, but to me it's interesting. Maybe not to you guys, but that's okay. The zeros are still 2 and negative 2, even though the graph is upside down. That's okay. Okay, so that's still 2, 0. That's still negative 2, 0. So right side up, upside down, doesn't matter. Okay, graph them like we did, but the answer, instead of being the graph, you need to kind of write, hey, the zeros are this and this. Okay, and for this kind of a graph, or the graphing that we're doing, it's going to be 2 and negative 2, 3 and negative 3, 4 and negative 4. We'll get into like the others down the road when it's like 1 and 8. You know, we'll get into that later. But for today, it'll be a positive and negative of the same number. Okay? All right. So that's all I got. Hopefully, we're going a little bit at a time. You're getting it, but we'll add the B part in tomorrow. All right. Have a great day, guys.